In this video, we'll look at how to find the area between two curves. We'll focus on two cases, curves with two intersection points and curves with three intersection points. As we know, the geometry area between f of x and g of x must always be positive. So first, we need to determine which curve is above the other over the interval of interest. For the special case of two intersection points, we can simply integrate the absolute value of the difference between the functions. With more intersection points, like three intersection points, we must split the integral into multiple sections. Like for this interval, the red function constantly dominates the green one. Here is the opposite. Let's break down both cases in detail. Let's walk through this example with two intersections to compare the manual and Python solutions. Step 1. Find the intersection points. Here the intersections occur at x equals 0 and 2. So we have the interval of interest 0, 2. Step 2. Determine the upper curve. Within this interval, we need to determine which curve is above the other. A simple way to do this is to pick a test point, say x equals 1, and compare y values of both curves. The curve with a higher y value at x equals 1 is the upper curve. If a graph is available, we can visually confirm the upper curve and skip this step. Step 3. Compute the area. Now subtract the lower curve from the upper curve and integrate over 0, 2. To skip step 2 and avoid graphing altogether, you can subtract the two curves in any order and simply take the absolute value of the result. This guarantees that the computed area is always positive. Now let's compute the area using Python. First, we'll import the necessary libraries. The symbolic expression for two functions. We use the symbolic solver function to get to the intersection points. Next is the visualization part. Two functions in regular form, and plot two curves, shade the area, mark two intersection points, adjust the plotting setting. So we get the area and the upper curve, lower curve, and two intersection points. Here is the result, is the area. Now let's compute the area between two curves with three intersections. We use these two functions in this example. We use fsolve from SciPy as our numerical solver to get the intersection points. Here is the visualization part. Shade the area and customize the plotting setting. So three intersection points and two shaded areas. Now we have the graph available. We can use the integration function in SymPy to get both areas. We must split the integral in two sections. One is over this interval and another is here. Then we add these two areas together. So we run the code, we get the total area about 2.2. This video focused especially on finding the area between two curves using intersection points as the boundaries. We did not cover cases where the area is computed over a given interval